Hey, what's up, grade 11s? This is Mr. Martens. Welcome to week 3. This week, guys, we're going to be learning some new stuff. Okay, we finished up with the if statements last week, and hopefully you're all caught up with your weekly lessons. If not, make sure you go back and do weeks 1 and 2 and submit the work before you start with week 3. But here we are on week 3. Now, for this week, before we get started, guys, I've kind of discovered something else that's cool about BlueJ. That's kind of a new, easy thing. So, you know when you download the templates and you get these jar files, and I've told you we're not using this papplet template anymore. We've got one that we copy and paste from D2L. But this console template is still okay to use. And in fact, we can use it in a very easy way by just dragging it and dropping it into a new project. All right, so maybe I'll back up a step. I'm going to delete this, and I will actually close this project. And I'll just show you, just a reminder from last week, we are basically starting to create weekly project folders with our username. So we didn't do this in the first week. I'm going to just delete this here because we don't need that. But we did start doing it last week, okay? And then I showed you how to zip this project folder and then upload it to Dropbox. And if you don't know what I'm talking about, you got to go back to week 2 to find all this out. So maybe I should start here, and we'll start with a new project folder. So File, New Project. Okay, make sure I'm in BlueJ. Here we go. Project, New Project. Okay, and we're going to use our username again. And I'm just making one up here. And this is going to be called week 3. Okay, so this is how we're going to start each week, with a new project, username, and then the week number that we're on. So getting back to these templates again, we can just drag and drop a console template right into BlueJ. All right, so we're going to need 4 of these for the first lesson that we're going to do today. I'm going to open this up, and I'm just going to rename it by changing the name of the class here. Okay, so I'm just going to call this for loop examples. Now you probably don't know what that means, but don't worry, we'll get to that part later. And then I'm going to just compile the class, and no syntax errors. So I'm going to close that off, and I'm going to, close that off. Try that again. Close that off. There we go. And so I've got my first sort of template ready to go. All right, so in this lesson, we're going to do 3 more programs on top of that. Okay, we're going to do one called Accelerate. So I'm just going to bring out another one of these guys, open it up, and change the name of the class to Accelerate. Okay, and compile and close. Okay, we're going to do one called Golf Score. So open that up and change it to Golf Score. And compile and close. When you compile, basically, guys, it saves the program. Okay, these are little things I haven't really just explained well enough. If I bring out another console template, notice that it starts out like all these lines in it. That just means we have an uncompiled class. It hasn't been saved yet. So if I open this up and then change this, so this last one is going to be called marks. Okay, and if I just close it and don't compile it, it stays, we'll call that dirty. It stays dirty. It's not clean like the other ones. All right, but if I select it, and I can compile it this way as well, and now it's cleaned up, it's compiled. Okay, similarly, if you make changes to any of these files and you don't compile them, they get these lines in them again. All right, so yeah, so that's how that works. All right, so we have 4 of basically the same console template right now that we're going to work with. So we'll start with our examples, and we'll just kind of move our way around the block here. So I'm going to open this first one up here, and we'll start with this. So this week, guys, we're talking about this topic of repetition. So repetition is a tool that programmers can use to have chunks of code repeat themselves. All right, and there's 2 main ways to do that. The first way we're going to look at is the for loop, and that's what we're going to cover in this video, the for loop. Okay, so let me show you how a basic for loop works. So just type this in with me. So for int x equals 0, semicolon, x less than equal to 10, semicolon, x plus equals 1. All right, and then close that off, and then give me a brace and then a brace. All right, so let me explain what we've just typed here. What we're doing is saying let x be a number that starts at 0 and keeps going up to and including 10. And let x increase in value by 1 each time. All right, so basically we've just created a number sequence that goes from 1 to 10, or 0 to 10 rather. Okay, and just to show you those numbers that x becomes inside of this loop, we can just go like this, c.print x, and we'll go like comma 5. All right, remember back in the old days we talked about console spacing? So this 5 here is just to space each number out by 5 spaces. All right, so I'm just going to compile that, and I'll just put this over here for a second, and I'll right click and I'll just run the main method, and you're going to see the numbers 0 to 10 appear sort of spaced out like that, all right, because of that comma 5. All right, so that basically generates a sequence of numbers. All right, so let's try a few variations of this for loop, and then we'll get into some actual examples of where you might want to use it. All right, so let's try another for loop here that goes backwards. All right, so we're going to go for, and this time I'm going to use a variable y. So I'm going to start y at 30, and I'm going to say y greater than or equal to 10. And I'm going to say y minus equals 1. Okay, so let me just put another brace here. Okay, so now we've got a variable y that's going to start at 30 and go backwards until it reaches 10, and it's going to decrease by 1 each time. So it's going to go 30, 29, 28, 27, and so on. So I'm going to go c.print y plus, this time I'm just going to put like a comma in between. Makes it look a little bit cleaner. All right, so we'll keep the x list there, and maybe in between these things I'll do like a c.print line, maybe like a new line. Whoops, can I do a backslash? Yeah, new line, and a bunch of these dashes and another new line like that. All right, so that's just going to put a bit of a gap in between each list of numbers. So I'll compile that, then it goes clean, and I'll right click and go main and run it. So now you're going to see y going backwards. Okay, so it kind of spills over to the next line, but that's not a big deal. So you can see it goes 30, 29, 28, all the way down to 10. Okay, so we're going up and we're going backwards. All right, let's do a couple of more examples. So for our next example, I'm just going to copy and paste this. So Control C, Control V. And this time we're going to have a value called num, or a variable called num. And it's going to start at, say, 5. And it's going to go up to, I don't know, 500. Okay? This time it's going to increase, so I got to change that to, say, num. It's going to increase by, say, 50 each time. All right, so let num start at 5. Let num go as close as it can without going over to 500. Let it increase by 50 each time. Okay, so now I've got to print num instead of y. Okay, it's a different variable. So I'm going to compile, and let's see what we get this time around. All right, so 5, 55, 105. See how it gets to 455? The next number would be 505 if it was allowed to go that far, okay? But we've told it, do not go past 500. Okay, so it goes as close to the ending number as it can without going over it. All right, and we can do the same. We'll do a fourth example going backwards again. Okay, so I'm going to just copy and paste this num example. And we can actually use num again as a variable. We don't have to change it just because we're doing a new list. So let's use num again. And this time we're going to go backwards again. Okay, so when you're going backwards versus forward, there's a couple of other really important things that you need to know. First of all, this number has to be the bigger number, and then this is the smaller number. So let's start this time at, I don't know, 1,000. Okay. Another way of saying the middle part is keep going as long as this is true. Okay, so what we're saying is keep going as long as num is less than 500. Well, the problem is it already fails on the first try, right? Because num is 1,000. Stop if num becomes less than 500. Well, it's already less than 500, so this loop's not going to go anywhere. Okay, even if I go like this, num like minus equals, I don't know, 100. Okay, so we're going to go down, and why don't we make this like keep going until you get to like, I don't know, 0. Or actually we'll go into the negatives. We'll go to like negative 200 or something like that. All right, now this loop isn't going to work. Okay, and again, it's because when I'm going backwards, this has to be the high number, this has to be the lower number, and this has to be minus. And all those things are true, but the problem is this sign here, okay? Keep going as long as I'm less than negative 200. That's not what we want to say. We want to say keep going as long as I'm over or equal to. Okay, so when you're going from high to low, it's basically greater than. Okay, when you're going low to high, like I am here, it's less than. All right, so there's that to consider as well. All right, so you can go in both directions, but you basically got to change 1, 2, 3, 4 things, right? You got to change this to a high number, this to a low number, this to minus equals, and this to greater than equals. Okay, so all those things are now in place for this backwards loop to work properly. All right, so I'm going to compile this and I'm going to run it and say okay. And sip a coffee while I'm waiting for this to go. Sorry, that went faster than my coffee went down. So there we have it. Okay, so it's going down by 100 each time, starting at 1,000, ending at 200, which is exactly what we said. All right, so far all you know about is this for loop generates a sequence of numbers. On its own, it's not very useful. But now we're going to take it into some other program examples, and we're going to see ways that we can use the for loop for like real world situations. All right, so we'll close that off. That's our first program done. And let's go to accelerate. All right, so in accelerate, we're going to basically say, pretend we threw like I don't know, a rock off a building, and it's going to take 10 seconds to fall to the ground. And as it's falling, it's increasing its speed, like by say, 10% per second. Okay, so we're going to count down 10, 9, 8, 7, 6, 5, 4, and then as time goes by, it's going to go faster by 10 seconds. And we're going to sort of calculate the speed it's at impact, like when it hits the ground, how fast is it going, based on that kind of model. All right, so let's open this up here, and we'll just get rid of the print statement. So we need a variable for speed. Okay, and let's say when you first drop it, you give it a little bit of a throw, and it starts at 20 kilometers per hour or something like that. All right, and so now we're going to do like a countdown of time. So I'm going to go like this: for int time equals 10 seconds, right? Keep going as long as we're greater than 0 seconds, because at 0 we hit the ground, right? So we're going to go as far as 1, and then on 0 we're going to be on the ground. So we'll go to 1, and then we're going to say like time minus equals 1. Okay, we could also say time minus minus. That also works, and you're going to see that more common. If you're just going down by 1 or up by 1, you can use plus plus. So I'll leave it as minus minus. All right, and in this one, we're going to basically start with a print statement, and we're going to say like at t minus 10 seconds, the speed is 20. Okay, so we're going to go like the c dot print line. Okay, and then inside of here, we're going to do a string dot format. That way we can use placeholders for our variables. So we're going to say at t minus %d seconds, the speed is %.2f, which is a placeholder for our double, right, which is speed. All right, so then we follow that up with comma, and the first placeholder for d is for time, and then the second one is for speed. Okay, we've done this before in the past, guys. Let me just open that up so you can see the rest of that line. But it's been a while since we've done string.format, but basically with string.format, you can print the whole sentence out and you can insert these placeholders where the variables are going to go. If it's a double, it's %.2f. If it's a integer, it's %d, and we can put them here. All right, anyway, so on to the next line we go. So we want speed to increase by 10%. So we can go like this: speed plus equals 0.1 times speed. Okay, so that basically says speed increase by 10% of yourself. Okay, so then when we're done that, it's going to do that for 10 seconds, and every second it's going to increase by another 10%, and it's going to keep printing. So when we get to the ground, we want to print sort of the final speed when it hits the ground. So outside of the loop, we can have a piece of code that runs one time on its own. So this print statement isn't in the loop, because the loop is this purple zone here in BlueJ. You see the color coding for that. Okay, so we're outside of the purple zone, so we're outside of the loop. So this happens one time at the end. So we're going to say the rock hits the ground at %.2f seconds. Okay, followed by speed. Now I just realized that I didn't put this into a string.format, so let me just do that really quick. So I'm going to put 2 brackets at the end, and I'm going to come to the beginning, and I'm going to put string.format. It's usually easier if you put that in first, but I had to go back and do it. So anyway, that should be our second program done. All right, so before we run it, we got speed starting at 20. We're counting backwards, 10. Keep going as long as we're greater than 0. Go down by 1 each time. Right, so this is going to go 10, 9, 8, 7, 6, 5, and the speed is going to start out at 20, and then it's going to increase by 10%, 10 times in a row, and then it's going to come out of the loop and print the final. All right, so compile that, and we will run it really quick. Okay, and there we go. So at t minus 10, the speed is 20. That's when we throw it off the building, and then it increases by 10% each time. So by the time it hits the ground, it's going 51.87. Actually, that shouldn't say seconds. It should say like kilometers per hour. So we could just fix that up really quick. So here we could say the speed is %.2f km per hour, because that's the actual speed in units. And this shouldn't be in seconds, right? This is also in kilometers per hour. My bad. All right, and so that should work now. No problem. Compile, and I'm going to run this. And that looks pretty good. All right, so there's sort of an application of the for loop and sort of a physics type question. All right, so let's go on to golf score. Now in golf score, we're going to keep track of the score of 9 rounds of golf using a for loop. So in the for loop, we're going to ask the person for each of their scores all the way through for 9 scores, and at the end we're going to print a little scorecard and tell them how they did for each hole and what their total is. All right, so we can use a for loop that goes through 9 holes of golf to keep track of it, and as we enter each score, we can add that to like a total score. All right, now this and the next example also introduce a new concept, guys, called an array. So let me show you really quickly what that's all about. Because I want to keep track of scores of 9 different holes in golf, I can go like this, int holes, and put square brackets around it. Okay, so these square brackets mean I'm going to have a list of ints. Okay, it's also called an array in Java. All right, now when I do that, I have to say how many are in the list right up front. So I got to go equals new int 9. Okay, just like that. All right, so this establishes like 9 little slots where I can store a whole value. Now, the only other thing that's kind of a gotcha with this is the slot numbers start at 0. Okay, so I end up with locations like this, like holes at 0, holes at location 0. That's what this means, hole at location 0. Okay, that's what I scored on the first hole. Okay, and then similarly, when you get to the end of it, holes at location 8, okay, not hells, sorry, holes, if I can spell that right. Okay, that represents the last hole, or hole number 9. So it's a bit confusing, especially for beginners, that we're off by 1. Like, the holes are 1 to 9, right? But the locations are actually 0 to 8. And that's just a programming thing. In all languages, it starts that way, with 0 as the first location. But as long as you are aware of that, then you should be okay. We can use a for loop to travel through each of the locations, 0 to 8, and fill it up with numbers. And then we can print a scorecard at the end. All right, so these little numbers inside the square brackets, which are like your location numbers, we can use a for loop to represent the numbers 0 to 8 to do that. All right, so let me just come back and erase this and show you how that works. All right, so I'm going to go, I'm also going to have a variable called total, which starts at 0. And then as each hole gets entered, we're going to add it into the total. All right, so I'm going to go for int x equals 0. X less than or equal to 8, x plus plus. Okay, so we're going to go from 0 to 8. All right, and then I'm going to go like this. C.print, enter your score for whole number, and then I'm going to say plus x. And then I'm going to go back in and I'm just going to draw like a little arrowy thingy here. Okay, just like that. All right, now if I run this, it's going to just quickly print, enter your score for hole 0, hole 1, hole 2. Okay, and let me just compile and run that and you can see what we got so far. So if I right click and I run this, you're just going to see that printed like 0 to 8. And actually it kind of does that, but because they're all print statements and not print lines, it all kind of prints out on one line. Okay, but it is sort of working. Now we don't want to say hole 0 to 8, we want to say hole 1 to 9. So when we go to print x, I'm going to actually just add 1 to it like this. Okay, now that doesn't change the value of x, that just temporarily adds 1 to it, so it's going to print a 1 when it's actually a 0 and so on. All right, now to store the actual answer into the location in holes, I go like this. Holes at location x equals c.readInt. All right, so that's going to store into that memory slot an integer, okay, from like 0 to 8. Okay, then at the same time we want to go total plus equals holes at location x. All right, and so that's going to add each of the locations into the total. All right, so that's going to fill up my scorecard with 9 different golf scores stored in a list called holes. All right, so now what I can do is I can print, so I'm just going to go like this as a comment, print the scorecard. Okay, and I can use a for loop to do that. Okay, so I'm going to go like for int x equals 0, x less than equal to 8, x plus plus. Okay, and then I'm just going to go, where is my cursor? Here we go. I'm just going to go like this, c dot print holes at location x plus maybe like a little box separator here. Okay, so that's going to print all of that out, and then I'm going to go c dot print line, go to a new line, and then maybe some dashes, and then another new line, and total, and plus the variable total. Okay, so I can just tack it on at the end if I want to, like that. All right, so once I'm done entering the 9 holes, it's going to print a scorecard of all those hole numbers, and then it's going to print the total. All right, so I'm going to compile this, and I'm going to run it. Okay, so enter score for hole number 1. So I shot a 4, and then a 3, and then a 2, and then a 5. Then I got a hole in 1 because I can get those. And I had a couple of bad holes at the end here. And then I come back and make a bit of a comeback. So once I enter this last hole, watch what happens. Okay, so then it comes back and it goes back through the list and it prints all the scores that I entered. So these are the same numbers as these ones, and then gives me a total of 33. Now if I wanted to print the whole numbers on top of that to make it look like a better scorecard, I can do that as well. Okay, so why don't I have another for loop that prints the whole numbers first. Okay, so I'm going to go like for int x equals, and this time I can just use like 1 to 9, x less than equal to 9, x plus plus, right? And I can basically do the same thing as I'm doing down here, but instead of printing the holes, I'm just printing the numbers from 1 to 9. So I'm just going to copy this and paste it up here. Okay, just like that. So, and this is going to be, instead of holes at x, it's just going to be the variable x. So this will generate the numbers 1 to 9 above the actual scores. Okay, now before I print those, I'm going to go c.println, and then I'm going to go like to a new line, and I'm going to print like a bunch of dashes, so there's like a separator between the whole numbers. I'm not sure how many I need. And then just like that, I guess. So that'll probably work. Okay. So this time around I'm going to do a perfect game. I'm going to get holes in 1 all the way through. Because in my fantasy world I can do that in programming. Why not, right? So I got 1, 1, 1. I really did. Okay, so watch what happens here. Okay, so there's my scorecard, and there's my hole numbers, and then there's what I got on each hole, and then my total is 9. So notice it's adding these all together. All right, so we could probably improve it by making a couple of more lines between here and here and making this line a little bit longer, but you get the gist of it. All right, so that's basically how that works. All right, so that brings us to our final program in this video, which is the marks program. So this is going to use 2 lists now. Actually, we'll just stick with 1. Let's keep it simple. So we're going to have a list that stores the 4 marks for your report card, and then we're going to print your report card. Okay, so we can store all of the marks into one variable called marks with 4 locations. So let's just open this up and we'll see what that looks like. So here at the top I can go like this. I can say int marks, square brackets to make it a list, equals, and we have to give it a size. So I'm going to give it a size of 4. Okay, so just like the golf score, we'll do the same sort of thing where we just enter the marks in a for loop, right? So we're going to go for int I'm going to use the variable I this time, just because it doesn't always have to be x. It can be whatever you want it to be. So this variable I starts at 0, I less than 4. Okay, so I can also do that. I can also go like this, guys, I less than marks dot length. Okay, this is more of a common way to do this. So when you're traveling through an array with a for loop, which is what you use for loops through a lot for, let me try that again. We use for loops a lot to travel through arrays. That's kind of one of their main purposes in life. We use a for loop that goes from 0 to less than, but not equal to, the length, because the length is 4. We don't want to get to the number 4, because we know that the locations, and I'm going to put this here, locations go from marks 0 all the way to marks 3. Okay, so remember that it starts at 0, so it goes 0 to 3. So if I say less than marks.length, I'm saying keep it under 4, so go as high as 3. And then I plus plus. All right, and then I'm going to do something very similar as I did with the golf score. So I'm just going to go c dot print, enter subject mark, and then I'm going to go out of this, and I'm going to go plus I this time plus 1, and then back in with a little arrowy thingy like that. All right, here we go. Enter subject mark, and then I plus 1. And then I'm just going to say marks at location I equals c dot read int. Okay, and then why don't we do an average while we're at it? So I'm going to say avg plus equals marks at location I. Okay, and that means if I'm going to do that, then I need a variable called avg, which I'll just make an int, and I'll start it out at 0, so it has a starting value, so I can increase it. Okay, and then at the end I'll just go c.println the average is plus avg. Now I know that's not the average, that's the total right now. So here I'm going to say avg equal yourself divided by 4. Okay, so when we're done adding up all the marks, we can divide it by 4, and then we get the true average. All right, so let's just try this one here, and we'll just run this. Okay, so it's going to just ask me for the marks, so enter. I got a 67, and I got an 82, and I got a 34 because I didn't do any of the online work I was supposed to do, hint hint, and I got an 88. Okay, and the average is 68, which I assume is the right number. All right, let's go a little fancier. I can also store the names of the subjects ahead of time in a separate list as well. Now, we're going to look at strings more detail in the future, but for now, in case you didn't know, a string variable holds a word. Okay, but it's not a primitive data type, so it's not like small I or small d. It's big S string. Okay, so I'm going to go string course or courses. Okay, I'm going to make it a list, and I'm going to initialize the list. I'm going to give it some starting values. This is something else you can do with lists. Okay, if you use curly braces, we can basically list out and fill this list up front. Okay, now notice we don't have to give it a size, because what it does in this case is it looks at the number of items separated by a comma, and from that it can determine how big it's got to be. Right, so I'm going to have like math or nath, and I'm just going to use like really short course names here. So gym, I don't know, drama, that's a pretty short one, and science. Okay, so those are my courses. Okay, so instead of saying enter subject mark I plus 1, I can say enter subject mark, and then I can say, we'll say it like this, enter mark 4, and then instead of I plus 1, I'm going to say courses at location I. Okay, so now it's going to say enter mark 4 math, and then gym, and then drama, and then science. Okay, so it's going to be a lot more readable. So I will compile that, and we will run that. Okay, so now it's actually got subject names, and I'm just making up some numbers here. Okay, and then the average is 63. We could, if we wanted to, print out like a report card, but this video is getting kind of long, so I think we'll stop there. That gives you sort of a gist of how the for loop works. In the next video, we're going to talk about the other kind of loop, which is called the while true. Okay, so stay tuned for that in part 2.